Okay, what I'd like to do right now is I'd like to go into the marble drop lab, and what I would like to do, first of all, is to draw a table. I would like to say, first of all, that I'm doing this with my fingers, so it's not the best example, but we had a ramp initially, okay, and we had a ball at the top of this ramp, a marble, and the marble rolled down to the bottom, and when it got to the bottom, it had a certain velocity in the x direction, okay? And once it got to the edge, it still had that same velocity in the x direction. And what I asked you to do was to find the distance in the x direction that it was going to be out whenever it hit the ground, and that's where we put the duct tape. Okay? So this is the duct tape right here. Okay? This is the duct tape. This is the ball, so the ball will be in blue. Alright? And what happened was that the ball followed a path into the duct tape. But I didn't give you any other information. So what we had to do, there were several steps. I'm just going to tell you what those steps were, and hopefully you can figure it out from here, okay? On the day of the lab, I made you figure it out, but hopefully you're just using this to remember by. So the first thing you had to do was recognize that we had to figure out stuff on the table. Pretend this table is... Since we had to figure out stuff on the table, we first had to decide whether or not we should start timing at the top of the ramp or the bottom of the ramp. What we were looking for was the velocity in the x as it leaves here. And what we recognized was that as it goes down the ramp, as it travels down the ramp, it is going to be accelerating. And so it's not until we get to this point that we can start solving for a velocity that it's going to have, because it's going to be a constant velocity from here to the edge of the table. And so what we did was we said the velocity in the x will be equal to whatever this velocity is here between these 2 points. And so we first found the distance between the end of the ramp and the edge of the table, and then we found the time from the end of the ramp to the edge of the table, and we saw that Vx was equal to d divided by t. Okay? Alright. The second thing we had to do was recognize that once the ball reached the edge of the table, it had an initial velocity in the x, and we were looking for a distance in the x. Well, if you'll remember, the formula for Vx is Vx equals dx divided by time. So we needed a time that it was going to take to fall. So what we did was we said, okay, if I'm looking for this distance in the x down here, I need to find the time it's going to take to fall this distance here. And the way we're going to have to use to find that is by calculating the time using a known height dy. So you can measure the height dy, and then you're going to use that then to solve for the time it takes to fall. So when we set this up, we're going to say that dy, the time it takes to fall, is equal to 1/2 ay t squared plus viyt. Now you should remember that if the marble is being dropped off or shot off of the edge of the table, it's only got a velocity in the x. The velocity in the y initially is equal to 0. So that is going to go to 0, and you'll be left with the distance in the y equals 1/2 times the acceleration in the y times the time to fall squared. So it's going to be the time to fall, and so the time to fall ends up equaling, if we use the math, ends up equaling 2 dy divided by the acceleration of the y square rooted. And that should get you your answer, okay? For your particular case, the answer should have been 0.38, I think, 38 seconds. The tables were 0.74 meters high. Okay, the last step then was we now have the time to fall equals 0.74, and you were, or sorry, not 0.74, it was equal to 0.38. And we also have a velocity in the x. We've done that calculation. It could change. Let's just say that we got Vx. It depends on how high your ramp was, but let's just say your Vx equaled 1 meter per second. So now what do we do to find the distance in the x? Well, we have our table here. We had our ramp here. The ball is going to roll down the ramp, off the table. It's going to have an initial velocity in the x. We know the time it's going to take to fall. So we need to know where is the place I need to put the duct tape in order for it to fall into the duct tape. Well, we now have time to fall and Vx, and we're looking for dx. And if we're looking for the distance in the x, remember we have to have velocity in the x equals distance in the x divided by time. And so in our case, I'm saying that the velocity in the x was 1 meter per second, so that's 1 meter per second. Distance in the x was unknown, so we'll plug in dx, and the time was 0.38 seconds. So if we solve for this, we get dx is equal to 0.38 meters, and that would be this distance here, and that's where you would put your duct tape. Alright, so hopefully that makes sense to everybody. If you weren't here on the day we did the marble drop lab, hopefully that helps you, and I hope you have a good day.